Okay, so today we're going to talk about VLANs and some of the use cases, why you would want to segment your network, why you would want to divide things up using virtual LANs. So let's go ahead and look at the desktop. Okay, so virtual LANs, essentially this is using server configuration, or pardon me, switch configurations to break up your network into logical units, to segments. And the reason that you would do this is to control network use and to segregate your network so that people from accounting aren't snooping into the information for people from HR and things like that. So let's go ahead and get started. We start off with a use case, participation activity. And then we have some definitions. VLAN database is a file a switch uses to store VLAN-related information. For example, a Cisco switch's VLAN database is stored in non-volatile memory. Non-volatile memory, by the way, is memory that does not lose information when the power is turned off. Think of volatile memory as RAM. So you've got stuff stored in RAM, and when your computer shuts down, if you haven't saved whatever it is to the hard drive, then that information is gone. This used to be a real problem back in the day before Word just decided to auto-save everything before the application died. You could be working on something and have a paper, with hundreds of pages that you had been working on. If you hadn't saved it, then the power went out and your computer shut down. All that work was lost. Nowadays, they have fault tolerance built into applications like Word or Excel, where what you're working on, if the power goes out or if the application hits a blue screen, for example, it will save your information before it shuts down, usually. Or it will create temporary files that you can then go back and restore or get rid of as you choose. So it's not as big a problem as it used to be, but it is still a problem. Volatile memory is memory that loses information when the power goes off. Non-volatile, that would be like a hard drive or a flash drive, something of that nature, CD-ROM even. It does not require power to maintain the information that it has. Default VLAN is a pre-configured VLAN type on all switches, allowing any connected device to communicate with connected devices. This is the default setting for any switch. Basically, what it means is that information coming through the switch is all on the same VLAN, and anything on that switch can communicate with anything else on the switch. So unless you have segmented that switch into VLANs, the default condition is everything communicates with everything. A data VLAN is defined as a VLAN type carrying user-generated traffic like email or web browsing. Voice VLAN, on the other hand, is tailored to support voice-over IP telephony traffic. Most companies today do not have standard landline telephones anymore. That's if you have a phone sitting on your desk, it's probably hooked up to the computer network rather than to the old phone system. In fact, the original phone landlines are, if they're not completely gone, they're going away very quickly. So voice VLAN is specifically engineered to support voice over IP telephone traffic. Management VLAN is defined as a VLAN providing administrative access to a switch. So this is a very limited VLAN. Usually only the administrator of that switch has access to it, and it provides access to the configuration portal rather than just open data. And then native VLAN is unused VLAN used to receive all untagged frames. So untagged frames are frames that don't have a VLAN tag. They probably came from a LAN or a switch that's too old to support VLANs. And so that is the traffic that would be on a native VLAN. Participation activity again, then port-based VLAN or interface-based or static VLAN. Port-based VLAN, known as an interfaced or static VLAN, is one in which the host is connected to a specific switch port that is assigned to a VLAN. So port-based, say you've got a 24-port switch, the first 4 ports belong to accounting. And so port-based VLAN, that means that only accounting computers will be hooked into those first 4 ports. That is port-based. That means that the actual physical network ports are what divides up the the VLAN. So ports 1 through 4 would go to accounting, ports 5 through 7 would go to HR, whatever, things like that. That's port-based. MAC-based, on the other hand, doesn't matter which port you're plugged into. There's an ARP table in the switch, and that's what designates the VLAN's configuration. So MAC addresses in the ARP table that are designated as accounting, doesn't matter what port they're plugged into, that information can only be shared with other MAC addresses that are designated as accounting in the ARP table. HR MAC addresses are designated within the ARP table, and they can only share with other HR. So there's two methods of configuring a VLAN. You can use ports, which is physical ports on the switch, or you can use MAC addresses, so that MAC addresses in the ARP table are designated as different departments, and those are what designate where the VLANs are. Or protocol-based, that means things that use TCP traffic can only connect with certain things, and things that use UDP traffic can only connect with certain things, and things that use voice over IP can only connect with certain things. So protocol-based, if it's the VLAN is segregated based on what protocol communication is used. MAC-based means that the VLAN is segregated on specific MAC addresses and how they're designated within the ARP table. And port-based, finally, it depends on what port it's plugged in. Another participation activity, a VLAN aware device is a more modern switch. It's aware, it understands VLAN membership, so you can segregate it. A VLAN unaware device, one that uses native VLAN because it does not understand VLAN. It's an older switch that will not work on a VLAN. When you plug it in, it doesn't understand segregation, so it's just going to blast everything out to everybody. Challenge activity, and at that point, then you should be complete with this section. All right, guys, so that is VLAN, the use cases for a VLAN in a nutshell. If you have any questions, let me know. Contact me in class or send me a message through the Canvas inbox, and I will do my best to help. In the meantime, have a good day.